Okay, let's do a quick recap from last week and even a little bit into the week before. Last week we learned about how to divide by powers of 10, 10, 100, and 1,000. And so I wanted to just show you just a quick recap. Remember when we divide, we move our decimal place to the left. So in the first problem you see there, 14 and 26 hundredths divided by 100, you simply would take your decimal point back 2 places and your answer would be 1,426 10,000ths. And when we multiply by powers of 10, we're going to the right. There's 1 0, so I would go over to the right one space here and put my decimal. So my answer would be 654 10,000ths. And again, here's another one where we're dividing. Remember, there are 3 zeros, so I need to go back 3 places. 1, 2, 3. This way with nothing in it needs a 0. So my answer to that is 0.010792. And the way you would read that is 10,792. Remember, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. So this number would be 10,792 millionths. Okay? Today we're looking at topic 7.6. How do I divide decimals by whole numbers? So it's going to look a little different than just moving decimal points. Remember, the only time you can move decimal points is when you're multiplying by 10, 100, 1,000. Okay? So let's start off with this scenario. The 3 children in the Diego family are equally sharing the cost of an anniversary gift for their parents. How much will each child pay? Looks like right here that they are buying them some flowers. And the flowers are going to cost $42.45. So our equation here would be the whole $42.45 that it's going to cost divided by 3, because there are three children. So we're going to divide that money into 3 equal parts. So if you'll look, the main thing that you need, I guess I should say the first thing that you need to remember when you are dividing decimals by whole numbers, let me get our problem written out here, is you are going to take that decimal, and I like to say bring that baby up. You're going to come straight up, and you're going to put it in your quotient, and you're going to forget about it. Kind of like we forgot about the decimal when we were multiplying until the very end. We take care of the decimal at the very beginning in division. Okay, so I've got it there, and now I'm just going to divide like usual. 3 goes into 4, 1. 1 times 3 is 3. Subtract, bring down. 3 goes into 12, 4. Whoops, my pen is being silly tonight. 4 times 3 is 12. Subtract, bring down. 3 goes into 4 one time. 1 times 3 is 3. When I subtract, I'm going to get a 1, and I need to bring down my 5. 3 goes into 15 5 times. 5 times 3 is 15. And I know that's going to zero out. So each of the 3 children will owe $14.15 as their part of the flowers for their parents' anniversary. How can we know for sure that's right? If you take your quotient, multiply it times your divisor, you should get your dividend. Okay, so that's always something you can do if you're not sure. Now, sometimes when we divide decimals by whole numbers, we have to do what we call annex zeros. And what I would like us to do now really quickly is watch a quick video on how to kind of know when you need to add a 0 at the end of your dividend so that you can divide a little bit further. So let's watch this video together.
We want to divide a decimal by a whole number. Here we have 4.3 divided by 2, and here we have 7.83 divided by 9. Remember, division can be expressed in several ways. To divide a decimal by a whole number, we'll first rewrite this as a long division problem. So we'll have 4.3 divided by 2. And this is a pretty straightforward process when dividing by a whole number. What we need to do is take this decimal point and move it up into our quotient. Once we do this, we can divide as we normally would. We first ask how many 2's there are in 4. That would be 2. 2 times 2 is 4. And now we subtract. That would be 0. And now that we already have our decimal point in our quotient, we can go ahead and ignore it, so we'll just bring down the next digit, which is 3. And now we need to determine how many 2's there are in 3, and that would be 1. 1 times 2 is 2. And we subtract, and that would be 1. But when dividing a decimal by a whole number, we can't use the remainder notation. We have to keep dividing until this decimal either terminates or starts to repeat. So the way we do that is we can add extra zeros here on the end of 4.3. Remember, adding a 0 to what would be the hundredths place value is not going to change the value of 4.3. So once we add this digit, we can bring it down and then ask how many 2's are in 10. Well, there are 5 2's in 10. 2 times 5 is 10. And now when we subtract, the difference is 0. So we're done, which means this decimal is terminating, and the quotient is 2.15, or 2 1500ths. Our second example is written in fraction form, but a fraction bar does represent division. So we'll set this up in the same way. We have 7.83 divided by 9. And again, as long as we're dividing by a whole number, we just need to move the decimal point up into our quotient, and then we can divide as we normally would, disregarding the decimal. So we first need to determine how many 9's there would be in 78. And that would be 8, because 8 times 9 is 72. And as long as this difference is less than 9, we know this 8 is correct. So we have 6, and this would be 0. Bring down the next digit, which is 3. And now we ask how many 9's there are in 63. And that would be 7. 7 times 9 is 63. This difference is 0. We've used all of the digits, so we're done. So this quotient is equal to 0.87, or 87 hundredths. And often what you'll see textbooks do is put a 0 in the ones column. It's not required, but sometimes you'll see it written like this. In the next video, we'll take a look at how we divide a decimal by another decimal.
Okay, so hopefully you saw there that the reason we do this is because when you're dividing decimals, you cannot use the remainder notation like we've been doing. You can't say it's 2.1 remainder 3 because we're talking about decimals now. So what the instructor was showing you there is you have to keep going until the decimal either terminates, which means ends, or until it starts to repeat. And once it starts to repeat, you can just round it in the hundredths place. So I want to show you. Let's work a few problems and let's see if we can figure out how this works. If you'll remember, the very first step when you are doing, hold on one second, let me pause just a second. Okay, the first step we need to do is always bring that baby up. So I'm going to go ahead and put my decimal there, so now I can forget it. And I'm going to say 4 goes into 6 one time. 1 times 4 is 4. Subtract, bring down. 4 goes into 24 6 times. 6 times 4 is 24. Subtract, bring down. And now 4 goes into 8 2 times. 2 times 4 is 8. And I ended up where it terminated, which means it stopped. There was nothing else to divide. It came out evenly. So $6.48 divided by 4 would be $1.62. Okay, let's look at this one. $7.32 divided by 3. First step, bring that baby up. Now you can forget it. 3 goes into 7 2 times. 2 times 3 is 6. Subtract, bring down. 3 goes into 13 4 times. 4 times 3 is 12. Subtract, bring down. 3 goes into 12 4 times. 4 times 3 is 12. It zeroed out, which means I can stop. It's terminating. decimal, and $7.32 divided by 3 would be $2.44. Okay, so there's a couple of good examples for us to look at. Let's try a couple more. This time it's not with money, but you use the same idea. You're doing decimals. First step, bring that baby up. 5 does not go into 4, but 5 goes into 45 9 times. 9 times 5 is 45. Okay? Some of you see this right here and say, it's even and I'm finished. But what you need to remember is there has to be something over this number. So you bring down that 0. Even though you know 5 doesn't go into 0, you have to have that place filled. Now you can stop. So $4.50 divided by 5 is 90 hundredths. If you look here, bring that baby up first thing. 50 does not go into 5, but 50 goes into 55 one time. 1 times 50 is 50. Subtract. Okay, there's nothing to bring down here, but we have learned that with decimal division, we cannot say remainder 5. So here's where I'm going to increase this bar and make it just a little bit longer, and I'm going to add a 0, and I'm going to bring it down. 50 goes into 50 one time. 1 times 50 is 50. Now I have zeroed out, and I know that 5 and 50 hundredths divided by 50 is 11 hundredths. Okay, so here was an example where it was not terminating until we added a 0. We had to add a 0 because we cannot have remainders when we do decimal division. Now, here's what I'd like you to do on your notes page. Part 1, if you'd work this problem right here. Part 2, if you would work this problem. So you may want to go ahead and pause the video now and get these 2 problems copied down. Remember how to set them up. Let me just remind you with this one. On your paper, it's going to look like this. There's your division house. You're going to have 1 and 90 hundredths divided by 19. Okay, so set it up and work it. First step, don't forget, bring that baby up. When you're finished with that, you can go on to the next, go ahead and hit play. And on part 3, I've got a little bit larger problem. I'd like you to work this problem on your notes page and come to class tomorrow ready to really practice this decimal division where we're dividing decimals by whole numbers. Have a great evening.